All right, we're in a new chapter, chapter 7, and chapter 7 deals with solving systems of linear equations. Now, through the course of this chapter, we are going to use different methods in order to solve systems of linear equations. At this time, there are three ways you can solve it. One way is by graphing. And to give you a brief definition of what a system of linear equations are, and it's showed up here in red, is it consists of a linear system, which is basically a line where it has two or more linear equations with the same variable. And if you look at the bottom where I have x plus 2y equals 7 and 3x minus 2y equals 5, that's an example of a linear system of equations. What we're trying to do when we're solving these is we're trying to find an intersection point of a line. So x plus 2y equals 7 is a line, and it can be represented in slope-intercept form, which is y equals mx plus b, which means is that you just solve for y. Same thing for 3x minus 2y equals 5. That is also a line, and unless both of those two equations has the same slope, we can make the conclusion that it's going to have an intersecting point. What it is, I'm not sure. But here is an example of being able to check an intersection point. I wanted some more room to work with here. Okay, that's a little better. Now, for example 1, they're asking us to check to see if the coordinate that they're given in the example is an intersection point for those two systems. So for A, I have coordinates 3, 2, and they want to know if that is an intersection point for x plus 2y equals 7 and 3x minus 2y equals 5. And how we determine that is we substitute in the value in for x and the value in for y and see if it holds true. So let's look at the first one here. I'm going to substitute in 3 for x and 2 for y, so I have 3 plus 2 times 2 equals 7. So I have 3 plus 2 times 2 is 4 equals 7. 3 plus 4 is 7 equals 7. So that checks out. That's the first equation is a true statement. If I go to the second one, I have 3 times 3 minus 2 times 2 equals 5. 3 times 3 is 9, minus 2 times 2 is 4 equals 5. 9 minus 4 is 5, and that equals 5. That holds true. So the only way that we can determine that a coordinate is an intersection point is that it must hold true for both equations. It can't just be for one and not the other. If it holds true for one and not the other, it would be a false statement. It doesn't mean that that they can't be a line. It just means that their intersection point is not the given one that it's represented. So let's look at example B. We want to see if 5, 2 is the intersection point for systems of 2x minus 3y equals 4 and 2x plus 8y equals 11. So let's look at the first equation and substitute in those values. So I have 2 times 5 minus 3 times 2 equals 4. So that's 10 minus 6 equals 4, and I have 4 equals 4. So that holds true. So for the first one, we're good. Now for the second one, I have 2 times 5 plus 8 times 2 equals 11. So now I have 10 plus 16 equals 11, which means that's 26 equals 11. That's not true. So even though that the first equation it held as a true statement, it did not hold up for the second one. So that means that the intersection point for example B is not 5 comma 2. It's something else. And it's kind of the first portion of getting started in solving systems of linear equations. If we were to graph this, this goes back to what we learned when we were dealing with slope-intercept form. We have our y-intercept and we have our slope. So we're going to use those same methods to help us find where the line is at and create an intersection point. So let's look at the first equation right here. So I have y equals negative x plus 4. As I can see, I have my y-intercept is at 4, so I'm going to go 1, 2, 3, 4. So that is where my y-intercept is located. For my slope, I see that it is a negative 1. So if we go back where slope is rise over run, which means that I'm going to rise up 1 unit and then to the left 1 unit, or go down 1 unit and to the right. And let's see here, let me make a line, kind of fits these. And that's the line y equals negative x plus 4. So if, cancel that. Now I have I just have y equals 2x minus 8, which means that I need to find the y-intercept, which is negative 8. So I go 1, 2, 3, 4, 5, 6, 7, 8. So this is where my negative 8 is located. That's where my y-intercept is. Now my slope is 2. That means I'm going to go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. That's where our slope is. So then when I make a line for this, this is the line y equals 2x minus 8. So now I'm looking at my both the lines. It appears is the intersection is right here. The intersection is at 4, 0. That's what I think. It looks like it. And the way you can do that is you can check by doing what we did in the first examples. So if I'm making the assumption that the intersection point is 4, 0, I'm just going to substitute in 0 in for y and 4 in for x to see if it holds true. So let's give it a try. So I'm going to use this equation first. So my y is 0, so I'm going to go 0 equals, and my x is 4, but I have a negative 4 plus 4. And negative 4 plus 4 happens to equal 0, so it checks out. The second equation, y equals 2x minus 8, I'm going to go 0 equals 2 times 4 minus 8. 0 equals 2 times 4 is 8 minus 8. Well, 8 minus 8 is 0. So it checks out. So it does hold true. Sometimes when you get a graph that has not as clean of values, like here we have 4, 0. Well, sometimes you might get something like 0.37, repeating, or comma 5.685 or something like that. Something that it would be very tough to graph using paper and pencil, but we do have ways to do this where we can use softwares and calculators. So if you look here, I have a graph, or I have two systems. I got 6x plus y equals 37, and I have 4x plus 2y equals 18. Now, what I need to do is, if I'm going to use a graphing calculator, which I have right here, there's some things I have to keep in mind. First off, step one is, even though I have a system, I need to put it in y equals mx plus b form. Okay, so I look at my 6x plus y equals 37, so I'm going to subtract both sides by 6x, which gives me y equals a negative 6x plus 37. And same thing goes for the second one. I'm going to go 2y equals negative 4x plus 18, because I subtracted 4x to both sides. I'm going to divide everything by 2, which then gives me y equals negative 2x plus 9. So I got it into y equals mx plus b form. Second is now I go to my calculator, and let's see if I can get my calculator. Here it is. So I'm going to turn it on, and it says push the y equals button. See the y equals button, which is right here where my cursor's at? I'm going to click on it. And it gives you a y equals already. So all you have to do is punch in these values in here. So the first one is 6x plus 37. Let me get the enter key. And the second one is negative 2x plus 9. So going to the steps, I type in those two equations, and I push graph. Graph is the button right here. So when I click on that, I get a graph. Did I do something wrong? I think I forgot to put the negative on this one. Oops, my bad. All right, that's better. In this case, let's see here. Negative 2x plus 37. All right, so I have my intersected point somewhere around here. I don't really know where it's at, but what I can do is, if you go to the directions, you press the second button, which is right here, press second, and then hit trace. And it comes up with value, 0, minimum, maximum, and then there you have the fifth one, which is intersection. So if you go down the cursor to find 5, go to intersection, click on it. It's going to ask you for one curve. So in essence, you're going to hit enter 3 times. 1, 2, 3. And now you see you have intersection. Intersection here is 7, comma, negative 5. And hold on a sec. Sorry about that. Okay. It says that the intersection is at 7, comma, negative 5. Now what I can do is I can check this if I so desire. Whoops. And substitute in negative 5 in for y, equals negative 6 times 7 plus 37, which gives me negative 5 equals negative 42 plus 37, and negative 42 plus 37 is negative 5. So that checks. And if I have negative 5 equals negative 2 times 7 plus 9, I got negative 5 equals negative 14 plus 9, and negative 5 equals negative 5. So that checks out. So 7 comma negative 5 holds to be a true statement. So you just have to use these directions if you have a graphing calculator. It's very helpful if you are struggling with some of these terms mathematically with other steps, in fact, and with other methods of solving systems of linear equations. Having the graphing calculator can be a useful tool, but it is nice to know that you can use other methods in order to solve systems. And that is how you graph systems of linear equations. Hope this helps. Till next time.